In this section, we're going to be taking a look at derivatives when we're given graphs and tables rather than when we're given the equation of a function. So this is kind of an extra section that I throw in here just to kind of solidify the concepts of the chain rule, the product rule, the quotient rule, and the meaning of derivatives. Okay? So we often have to do this. We often have to examine functions when we're given a table or a graph for the function instead of the equation of the function. Okay, let's say that we're given this function f whose graph is given. Okay, how many values of x between a and b is f prime equal to 0? Well, f prime is 0. That means that we have a horizontal tangent line. The slope is 0, right? The slope of the tangent line is 0. So a horizontal tangent line. So how many spots have a horizontal tangent line? I see one here, one here, one here, and one here. At x is equal to 0, that is not a horizontal tangent line. That's a cusp. So there are 4. What about how many values of x have a non-existent f prime of x? That means that we have either, there are 3 things that make f prime non-existent. That's when f is not differentiable, right? We could have a cusp. We could have a discontinuity, any kind of discontinuity that would take into consideration holes, jumps, or holes, jumps, or a vertical asymptote. Or we could have a vertical tangent line. Okay, so how many places have either a cusp, a discontinuity, or a vertical tangent line? I only see one of them, and it's a cusp, and it's right here. So just a 1. How many times does the sign of f prime change? The sign of f prime. So f prime would be changing from negative to positive or positive to negative, which means that f would be changing from increasing to decreasing, or vice versa. Right? That would be f prime positive to f prime negative, or the other way around. So right here, f prime is negative. The slope of the tangent line is negative. So f is decreasing. But here f is increasing. So right here, f prime changed signs. F prime also changes signs at that maximum. F prime also changes signs right here, because here f prime is negative, here f prime is positive. Right? Here f prime changes signs, here f prime changes signs. There are 5 of them. Okay? So the sign of f prime changes when f has a relative min or a relative max. Okie doke. Number 2. Excuse me. Let's take a look at this graph of f. Consider the function f whose graph is given. They tell us that h is defined to be 2x times f of x, and they ask us to find h prime of negative 4. First, I'm going to find h prime of x, and then I will plug in negative 4 for x. I see a product of 2 functions here, so I must use the product rule. The derivative of the first function is 2. Multiply by your next function left alone, plus The derivative of f is f prime multiplied by the first function left alone. Product rule. Now we're going to plug in -4 for x. I'm starting with this 2. What is f of -4? Let's go to the graph. Here's -4. So f of -4 is -2 plus f prime of -4. F prime of -4 is the slope of the tangent line. Well, since this is linear, the slope of the tangent line is the slope of that line. And the slope of that line, I see that we're going up 2 over 1, so the slope of that line is a positive 2. And then 2 times -4 is -8. So this is -4 minus 16, or -20. Answer choice A. Next up, here's the graph of function g. If f is defined by g of g of x, what is the value of f prime of 0? First I'm going to find f prime of x, and then I'll plug in 0 for x. Okay, to find the derivative, we need to use the chain rule. I start on the outside, and I take its derivative. Outside derivative. Keep your inside the same, and then multiply by the derivative of your inside. And the derivative of our inside is g prime. Chain rule. And now I'm going to plug in 0 for x. Okay, first thing I see is g of 0. G of 0. G of 0 is 3. It's right there. And then I'm multiplying by g prime of 0. G prime of 0. Well, g prime of 0 is the slope of the tangent line. And since this is linear, it's the slope of that line. And the slope of that line is 2, up 2 over 1. And now we're going to find g prime of 3. I go over to where x is 3. Here's g of 3. G prime of 3 is the slope of the tangent line. And since this is linear, it's just the slope of the line. So I'm going down 3 and right 3. That slope is a -1. So f prime of 0 is -2. Next up, number 4. The graph of g is given. Find f prime of -1 if f is g of x. Same thing that we did up here, just a different value of x to plug in. So f prime of x is still g prime of g of x times g prime of x. Keep your inside the same. Don't change it. Keep your argument the same. Multiply by the derivative of the argument. This is your argument here. All right. F prime of -1 now. Okay. G of -1. Here's -1. G of -1 is 1. Times g prime of -1. G prime of -1 is the slope of the tangent line right here, and that slope is up 2 over 1, so that slope is 2. Now we need g prime of 1. I go to when x is 1. When x is 1, we're right here. What is g prime at 1? G prime at 1 is non-existent. It does not exist because g has a cusp at x equals 1. G has a cusp at x equals 1. That's why. Okay? So this piece right here is non-existent. Can you multiply a non-existent by 2? No. The answer here is E, non-existent. Okay, next up. So that was when we have a graph of a function given. Okay, what if we have a table instead? We're going to do these the same way. Alrighty. We're given h. We want to find h prime of 6. So first I find h prime of x, and then I plug in 6 for x. We're going to use the chain rule here. We start on the outside and take the derivative. Keep your argument the same, and then multiply by the derivative of your argument. Chain rule. Now we're going to plug in 6 for x. G of 6. G of 6 is 4. G prime of 6. G prime of 6 is E. And now we find f prime of 4. F prime of 4 is pi. So we have pi times E. Pi E or E pi, either way. Alrighty, what about this one? Okay, find h prime of 4. I see a quotient, so we have to use the quotient rule. I start up on top and I take its derivative. The derivative of the top is 2g prime of x. I multiply by the bottom left alone. Minus is in the quotient rule. Now I go to the bottom, take its derivative. The derivative of the bottom is f prime. I multiply by the top left alone. The quotient rule has a quotient. The bottom of the quotient is the bottom squared. No derivative, the bottom left alone, but squared. And now we plug in 4 for x. G prime of 4. G prime of 4 is negative 1. F of 4. F of 4 is negative 2. F prime of 4. F prime of 4 is pi. 2. G of 4. G of 4 is 5. Divided by f of 4. F of 4 squared. So if this was a free response question, I would stop right there. That is a safe stop spot. But these will likely be multiple choice questions, so I'm going to go ahead and clean this up. This is 4 minus 10 pi all over 4. They would at least factor out a 2 from the top and reduce 2 and a 2 in the bottom. That would leave me a 2 minus 5 pi over 2. They might do that. They might, I don't know, they might write this as 1 minus 5 halves pi. I am thinking that this would be the multiple choice answer though. Okay. Alrighty, next up, part C. Find h prime of 6. Got to use the chain rule. Usually after today, kids know the chain rule pretty good when it comes to function notation in here. Start on the outside, take the derivative, leave your argument alone, and then multiply by the derivative of your argument. And now we're going to plug in 6 for x. Okay, so I need f of 6. F of 6. F of 6 is 4. And then I need f prime of 6. F prime of 6 is negative square root of 5. Now I need f prime of 4. F prime of 4 is pi. Multiple choice, they would just pull out that negative and write it like this. Okay? Part D. Now we need h prime of 4, where h is given like this. Okay, there are two terms in h. I see a product for one term, and then I see this other term left alone. We're going to need to use the product rule on this. and then multiply by, or subtract the derivative of 4g of x. So I'm going to begin with the product rule here. I start with the x, take its derivative, multiply by f of x left alone, plus. Now I'm leaving the x alone and multiplying by the derivative of f of x, f prime of x. Now let's go to the negative 4g of x. Its derivative is negative 4g prime of x. Alrighty. Plug in 4 for x. I have 1 times f of 4. F of 4 is negative 2. So that's going to be a negative 2 plus x, which is 4, times f prime of 4. F prime of 4 was pi, minus 4 times g prime of 4. G prime of 4 is negative 1. So we have negative 2 plus 4 pi plus 4, which is 2 plus 4 pi. Multiple choice answer. Okay? Free response must be all numbers, no function notation. So free response, this is our first safe stop spot. You cannot stop when you still have function notation. And I hear it all the time, but Miss Murray, there's a table that has those values in it. Why can't we safe stop right here? Because AP won't let you. If you want credit, you've got to write down the value of the number. That's all I can say. Which means this is not a safe stop spot because we still have function notation. This is a safe stop spot. This is not a safe stop spot. The next line is where we have all numbers. That's safe stop. Okay? Alright, next problem. The table on the right gives values of the differentiable functions f and g and their derivatives at x equals 1. Find h prime of 1. We're given h. I see here a product of 2 functions. So I need to use the product rule. I start with the first function and take its derivative. The derivative of this first function is 3f prime of x. I multiply by the second function left alone. Plus, now I go to the second function and take its derivative. Its derivative is just g prime of x. And I multiply by the first function left alone. And now I'm plugging in 1 for x. F prime of 1 is negative 2. G of 1. G of 1 is a negative 3. G prime of 1 is 4. F of 1 is 3. This would be a safe stop spot. All numbers. Safe stop spot. But cleaning it up for a multiple choice question, we'll have 4 times 9 minus 1 is 8. That is 6 plus 32, which is 38. That would be the multiple choice answer. Okay? Doing good, rolling right along. We get really good with all of our rules when we do it like this. We don't have to get bogged down in the equations. Okay, last one here. Okay, we're given f and g. They're telling us that both are twice differentiable and their derivatives. Okay, find h prime of 3 when this is h. So first we find h prime of x, and then we plug in 3 for x. What is the derivative of f of 2x? Well, this is chain rule. So we start on the outside and take its derivative. Keep your argument the same. Multiply by the derivative of your argument. Plus. Another chain rule. Start on the outside. Take its derivative. Leave your argument alone and then multiply by the derivative of your argument. Chain rule. Okay? Now we're going to plug in 3 for x. Alright, when I plug in 3 for x, I'm going to get a 6 right here. And I'll have f prime of 6. And f prime of 6 is negative 3. When I plug a 3 in for this x, I'm going to have 9 minus 3, which is 6. So I'll have g prime of 6. And g prime of 6 is 2. When I put a 3 in for that x, I get a 6 right there. That's our first safe stop spot. I'm going to go ahead and clean it up for a multiple choice question. Okay, part B. I see a quotient, so I need to use the quotient rule to find h prime, right? So h prime of x first, and then we'll plug in 6 for x. For a quotient rule, I have to start up on top and take its derivative first, and you must do that. You cannot start on the bottom for the quotient rule. You have to start up on top. Start up on top, take its derivative, that is g prime of x. Multiply by the bottom left alone. Minus, is in the quotient rule. Now I go to the bottom and take its derivative. The derivative of 2f prime of x is 2f double prime of x. And I multiply that by the top left alone. Divided by the bottom left alone but squared. What is the square of the bottom? In fact, I'll write it like that. The bottom left alone but squared. I say it like that because this 2 is going to be squared as well as the f prime. Okay, now I am going to plug in my numbers. I think I'm just going to go right over here and do it so I can see all the numbers up here. Okay, well, no, I can't do that, but I will do this. I don't want to put an equal to sign there if I'm going to plug in numbers, because this is not always equal to this thing with numbers in it. Okay? Just leave yourself a space, write what you're doing. This is h prime of x. This is going to be h prime of 6. You always want to communicate what you're doing. Okay? Don't just write equals, 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 equals if they're not equal. All right. G prime of 6. G prime of 6 is 2. Times this 2 times f prime of 6. F prime of 6 is negative 3. Got that too. F double prime of 6. F double prime of 6 is 3. G of 6. G of 6 is negative 2. All over the square of 2 f prime of f prime of 6, right? Well, the square of 2 is 4, and the square of f prime of 6, what's f prime of 6? F prime of 6 is negative 3, and we have to square that. Okay? Alrighty, so this would be, now I can put equals because I'm just cleaning it up. This would be a safe stop spot though, right? If this was an FRQ, you would stop right there and you're done. Don't go further. Don't clean it up. Okay, this is negative 12 plus 12 over 36, but that is 0. Multiple choice, that would be 0. Okie doke. Part C. Find h prime of 6. So first we're going to find h prime of x, and then we'll plug in 6 for x. Another quotient. We start up on top and take its derivative. The derivative of the top is 3f double prime of x. Multiply by the bottom left alone. Minus is in the quotient rule. Go to the bottom, take its derivative. The derivative of the bottom is g double prime of x, multiplied by the top left alone, all divided by the bottom left alone, but squared. Okay, now we plug in 6 for x. I got this 3. I need f double prime of 6. F double prime of 6 is 3. G prime of 6. G prime of 6 is 2. Minus g double prime of 6. G double prime of 6 is negative 5. Times 3 times f prime of 6. F prime of 6 is negative 3. Divided by g prime of 6 squared. G prime of 6 is 2. That would be a safe stop spot. And clean this up in the case of a multiple choice and question. So 9 times 2 is 18. I'm looking at my signs. I have 3 negatives, so that's going to be a minus. 9 times 5 is 45, right? Over 4, let's see, 18 minus 45. 18 minus 45, let's see, 15 and 7, is that 27? Is that right? I think so. Negative 27 over 4. Alrighty, so that is derivatives, product rule, quotient rule, chain rule, given the tables or graphs.